Hi everyone, this is Murli Manohar. Here I am going to solve a previous year question of GATE 2021, which is of 2 marks and was asked in electrical engineering branch. So in this circuit, a resistance of 4 ohm is connected in series with a inductor or with a coil of 6 Henry. On the other side, the coil of 4 Henry is connected to a resistance of 5 ohm, and these two coils are mutually coupled, and the mutual inductance value is given as 1 Henry. So in this circuit, input impedance is asked in S domain. Options are given. This circuit is mutually coupled circuit. First I will try to explain you the significance of this dot convention. So let us suppose there are two coils, and if current enters the dotted terminal of one coil, then mutually induced voltage in the second coil has a positive voltage polarity at the dotted terminal of second coil. If current enters the undotted terminal of one coil, then mutually induced voltage in second coil has a positive voltage polarity at undotted terminal of the second coil. So the current, let us suppose current I1 is flowing in the first coil. So and current I2 is flowing in the second coil. So there are two voltages, two induced voltages in first coil as well as in second coil. One is self induced voltage and other is mutually induced voltage. Self induced voltage is due to the current I1 and mutual induced voltage is due to the current I2. So it is easy to explain or understand the dot convention in other way. Let us suppose there are two coils, and if current enters the dot in both the coils or leaves the dot in both coils, then mutually induced voltage add the self-induced voltage. What does it mean? It means, so let us suppose current I1 enters the dot in first coil, and this is the polarity of this plus minus is the polarity of self-induced voltage. Same in second coil, this polarity is of self-induced voltage. Let us suppose there are two induced voltage in one coil, one is self and other is mutual. This is the polarity of self-induced voltage, this plus and minus, and we can represent the mutual induced voltage by a current dependent voltage source, and we have to give the polarity such as this is adding this self-induced voltage. In other case, if current enters the dot in one coil and leaves the dot in other coil, so here mutual induced voltage will oppose the self-induced voltage. How? Let us see here. This is this plus minus is the polarity of self-induced voltage. Here this plus minus is the polarity of self-induced voltage in coil 2, because current will always flow from higher voltage to lower voltage. So this will be the polarity of self-induced voltage, and here we have given the polarity of mutually induced voltage in such a way so that this mutually induced voltage is opposing the self-induced voltage. Here also this mutually induced voltage is opposing the self-induced voltage. Now in simple words, we are representing the mutually induced voltage by a current dependent voltage source, and we will give the polarity of this current dependent voltage source in such a way such that if current enters dot in both the windings, then it will add the self-induced voltage, and if current enters the dot in one coil and leaves the dot in other coil or vice versa, then it will oppose the self-induced voltage. Now coming to the question, we'll solve it in S domain only. Let us suppose I1S current is flowing in this circuit and I2S current is flowing in this circuit, and here the voltage is V1S. Now we'll try to represent the induced voltage in each coil due to mutual inductance with the help of a current dependent voltage source. So how we can represent it? Here in this circuit, current is entering in dot of one coil and current is leaving the dot in other coil. So in this case, mutually induced voltage will oppose the self-induced voltage. So how can we represent it? This is your 5 ohm. Here it will be SL. If L is the inductance, what is the impedance in S domain? It will be SL. So here it will be 4S. Here it will be 6S. It is 4 ohm. If M is the mutual inductance, what will be the impedance? It will be SM. So S I2S. Here it will be S I1S. How? Because if M is the inductance, what will be the voltage? It will be M di upon dt. In S domain, the voltage will be SM IS. Let us suppose this is V1S. Now the thing is, we need to give the polarity. How will give the polarity? Current is flowing in this way, so this will be the polarity of self-induced voltage. Here this will be this is plus, this will be the minus. This is the polarity of self-induced voltage. Now the mutually induced voltage is opposing the self-induced voltage, so here the polarity will be like this. Here also it will oppose, so the polarity will be like this. Now we just need to apply the 2 KVL, one in this circuit and other in this circuit. So just by applying KVL, let us suppose this is circuit 2, this is circuit 1. 2, what we will get? It will be minus SI1S plus 4S I1S plus 5 I1S. Okay. So by just applying the KVL in loop 2, we can write the equation as minus S I1S plus 4s I2s plus 5 I2s. So from here, what will be the value of I2s? I2s, it will be s I1s upon 4s plus 5. So let us suppose this is equation 1. And now, so here, just by applying KVL in loop 1, what will be the KVL equation? Minus B1s plus 4 I1s plus 6s I1s minus s I2s. It will be 0. Now, if we see, we need to calculate the input impedance from here. So the input impedance will be equal to V1s upon I1s. Here we need to replace the I2s in terms of I1s, so that we can get an equation which is in V1s and I1s, and we can calculate the ratio of these two, so that we can get the input impedance. So what can we do? So here s upon 4s plus 5 into s I1s. Now from here we can calculate the value of V1s upon I1s. What is it? It will be so Z input s will be V1 upon V1s upon I1s. It will be 6s plus 4 into 4s plus 5 minus s square. So it will be 24s square plus 30s plus 16s, 46s plus 20 minus s square. So ultimately what will be the value of input impedance? It will be 24s square minus s square, 23s square plus 46s plus 24s plus 5. This will be the value of input impedance of this circuit. So the correct option is option A. Thank you.